Okay, lesson 4 is on parallelograms. You could do most of this lesson yesterday. I'm not going to teach you very much new stuff today. Who can tell me, Carter, do you have a question? Lesson 4. Remember, mine doesn't have page numbers, so how do you find lesson 4? Yep, but look in the top right corner. Teach him how to get there, because will Dane always be there to tell him the page number? No. Look in the top right corner. It tells you what lesson it is, okay? So lesson 4 is on parallelograms. I know your lesson 4 parallelograms is in a big green box at the top, but right under your big green box or right above your big green box, do you have some white space? Yeah. Yes, we are going to write the definition of a parallelogram. I'm going to write mine right here next to it. You can write it above your big green box. Your box is about right there. Or you can write it below your big green box. Who thinks they can help me get started on the definition of a parallelogram? Jack?
A quadrilateral.
Okay, let's stop there. A quadrilateral. Nate, what does the word quadrilateral mean?
A four-sided shape.
Okay, a four-sided figure. So a parallelogram has to be four-sided. What else? Chase?
It has two sets of
He's on the right track. Has two sets of what, Jude?
parallel sides.
Parallel sides. A quadrilateral with two sets of parallel sides. Okay, so that is a review. What does a standard parallelogram kind of look like? Jack?
Like it's slanted kind of.
It's kind of like a rectangle that was kind of pushed over a little bit. Like its feet stayed put, but its top was kind of pushed over. It was kind of a slanted rectangle or a slanted square. Once you have that definitions, go down and look at 4.1. It shows us 6 pictures. And if we read, it says figures A, B, and C are parallelograms. So it is telling us those are parallelograms. Figures D, E, and F are not parallelograms. So it's saying the top ones are, the bottom ones are not. In this book, we're not going to go do these things down here at the bottom, but I want to point out, it says study the examples and non-examples. What is a non-example? Nolan?
Like an example that's not right.
Yeah, it's like an incorrect, it's like a false statement. Instead of saying which one, like, are they parallelograms, true, false? Trues would be the example. The false statements would be the non-examples. It's kind of showing you that this is the wrong way to do it. So it told us that A, B, and C are parallelograms. So to prove it, does anybody remember what symbols we can put on shapes to show that two sides are parallel? Chase? Slash tick marks show that they're the same length, which is congruent, which in this case, that is also true. We're not going to label all these, and I might not have even taught you this last year. I can't remember. Naomi?
Like just 2 lines with number 11 on it?
Nope, that's like the symbol, like in our notes in a second, we're going to use that symbol instead of writing the word parallel. Jack?
Like
the little arrows, yeah. So we'll show it on this one, and we're not going to do it on all of them. But to show, like, this side is parallel to this side, we would put like one little arrow or triangle on each one. That's one set of parallel sides. Go ahead and label that one. Where's the second set of parallel sides? Dane?
On the top and bottom.
On the top and bottom. How would we show it different? Because if I put one arrow, it's saying that it's parallel to those two.
Put 2 arrows?
Yeah, you put 2. And again, this is just a refresher. This isn't super important today. I'm just going to keep throwing it out there at you. So now let's check B. Does it have 2 sets of parallel sides?
Yeah.
Yeah, the left and the right are parallel to top and bottom. What about C?
It
Yeah, Bryce, what shape is that?
Where?
Square. I'm glad he said a square and not a diamond. What is a diamond? Sadie?
It's like, it has like slants on the sides and then it's flat on top.
Chase, what is a diamond?
A square flipped.
A square standing on one vertex, on one point. Okay? A diamond, remember, is not a geometric shape. When you guys think diamond, you're thinking of like a stone, like the shape of a stone, or you are thinking like this shape, which is a kite. Okay, again, getting off. I'm just trying to refresh your memory on lots of stuff we talked about last year. Now, D, E, and F, it tells me those are not parallelograms. We're going to tell why. Who can give me a reason why D is not a parallelogram? What is wrong with it? Dane?
There's no parallel sides.
There are no sets of parallel sides. So let's write that out to the side. No sets of, and here's where Naomi said there's a symbol, so we don't have to write the word parallel over and over. We're going to write the word once, P-A-R-A-L-L-E-L. But in parentheses, we're going to write the symbol. She said like an 11, but that's why we slant it, so that it doesn't look like an 11. If you do two parallel lines, and I always just try and darken them in so they stand out a little bit, we can use that symbol in place of the word parallel. So no sets of parallel sides. So in the next time we have to write that word, we'll just do the symbol. Okay, but again, don't put them straight up and down because then it does look like an 11. Just slant. Don't put them completely sideways because then what does it look like? An equal sign. So we kind of go between an 11 and an equal sign. What about E? Actually, sorry. Go back to D for a second. What can we call D? What is the proper name of D? Bryce?
Trapezoid?
Not a trapezoid. Anybody know? Jack?
An irregular rectangle?
No? Okay, we'll come back to it. We'll come back. E. Does anybody know why E is not a parallelogram, Sadie?
There's only one set of parallel sides.
Okay, she said there's only one set of parallel sides. If I look, you don't have to shade these in. There's those two are parallel. These two are parallel, and that one's parallel. So it actually has three sets of parallel sides. So that is, the parallel sides is a reason. So let's write has three sets. Do our symbol, parallel sides. Oops. And parallelograms only have two. Livy, what else?
I was going to say it's because it only has it has more than 3 sides. I mean more than 2 parallel sides.
Okay, so yeah, it has three sets. Jack?
It's not a quadrilateral.
It's not a quadrilateral. What is it? A hexagon. So up here where it says E, let's write that it's a hexagon. That's the proper name. And I'm going to add another bullet point down here. You guys can write it wherever. I'm going to kind of squeeze it right in here. It has more than 4 sides. Okay, so the two criteria that kick it out is it has more than 4 sides and it has too many sets of parallel sides. F. Why is F not a parallelogram? Sophie? Okay, you're right. It is comparable to, it has some features that a triangle has. Cooper? It only has one set of parallel sides. So this one's out because it only has one set of our symbol, parallel sides. Is it 4-sided?
Yeah.
So it is a quadrilateral. Does anybody know what we can call that shape? Trapezoid. The definition for trapezoid is a quadrilateral with one set of parallel sides. So it is a four-sided figure with one set of parallel sides. So it is a trapezoid. Now we're going to go back to D. Why is D not a trapezoid? Bryce?
Doesn't have two sets of parallel.
That's why it's...
One set of
Okay, yeah, it's not a parallelogram because it doesn't have two sets of parallel sides. It's not a trapezoid because to be a trapezoid, I need one set of parallel sides. It has no sets of parallel sides. Livy?
Is it an irregular parallelogram?
No. Good guess. Irregular parallelogram. Nope, no such thing. You guys are getting too specific. This is one that it's just a very general name. Jack? It's just a quadrilateral. Why?
Because it doesn't have any of the sides that are even, and it has no sets of parallel sides.
Correct. Yes, that is as specific as we can get. Do you need me? Okay. Okay. Once you have that, go ahead and turn the page. So, the problems we're about to do, Chase, you've already done problems like this. You're finding the area of weird shapes. How do we find the area of weird shapes, Harper?
You count the boxes.
Nope. We can't count the boxes because the boxes aren't always there.
Oh, you have.
Naomi?
You have to rearrange and decompose it.
Decompose and rearrange. When we decompose and rearrange, what are we trying to get?
Oh,
Nolan?
the rectangle.
Rectangles and squares because
Those are easy.
those are the easiest. Pull out your patty paper if you have it. If you need a new one, come grab one. But again, one should last us a while, but if you've used it quite a bit, go ahead and come grab a new one. And this is where your book and my online book look slightly different. Is this? Nate, I'm going to steal your book for a sec to make sure that's the same. Okay. Okay. We have a parallelogram. We're looking for rectangles. Jude, do you see a rectangle somewhere in that parallelogram, or is anything jumping out at you?
Not really.
Nothing jumping out on you on what we could do to find the area. Again, your guys' I'm looking right here. Your guys' is shaded in blue. Mine's white. Ethan?
I see two triangles.
Okay, so he's noticing that he sees two triangles. Where?
Like at the corner, top corner.
So like right here?
Yeah.
And he's seeing that one right there? Okay, so does everybody see that? What do we know if we have two right triangles that are the exact same size, Carter? You could rearrange them into a rectangle. But they have to be the same size. How can we make sure they're the same size? Livy?
Count them.
You could, more specific, count what?
Like count the inside.
You could count all of the inside, but what if it's not on grid paper? You could use patty paper. You could also just count like down here. This one is 3 on the flat bottom side, and 1, 2, 3, 4, 5, 6 high. 1, 2, 3, 4, 5, 6 high, and 1, 2, 3 on the bottom. Okay? What would we now probably do if we're trying to find the area? Chase?
Form the rectangle.
How?
Take that square and move it around.
Yeah, and do we have to flip it or rotate it at all? No, on this one, we just have to chop it off and just slide it over. When you slide it over, make sure you make it the right size. So at the top, I need 1, 2, 3 boxes. 1, 2, 3 boxes, and then straight down. Now, I know when you're doing these, there's a lot going on. Once I have the shape that I'm wanting to find the area to, I try and darken it in. Okay, with a pencil it's a little bit harder, but you can do it with a pencil. You just want to make it darker so you're looking at the right figure. Now that I decomposed that one right triangle off of the left side and moved it over to the right side, what shape do I now have? Reese?
A square.
Yeah, a square or rectangle. How do we figure out our area now?
You count.
Don't tell me to count the squares, all of them. I count something. What do I need to count? What's the formula for area of a rectangle?
A equals 1/7.
Okay, start with A equals L times W. Haley, how do I find my length and my width? Yeah, on this one we have to count it. Sometimes it's there if it's not on a grid. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Substitute. Solve. What is my label? Chase?
36 units squared.
Units squared. Always double check the words. Up at the top and make sure it doesn't tell us a different label. Does this one give us a different label? Nope, so it is just square units. We are finished. Shh. Okay, now, I don't want you guys to erase, but I'm going to show you something about parallelograms. This isn't just this parallelogram. This is, I'm going to say 98% of them. You could chop it anywhere and slide it. If I chopped it here, I guess not anywhere because I couldn't chop it there. If I chopped it right there and slid that over, I have to add 1, 2, 3, 4 boxes at the top. 1, 2, 3, 4 boxes at the top. Go down, and I chopped off one full box. There's my full box. It would still be 6 by 6. Okay, so on this one, I've taught you to look for those right triangles because two right triangles that are the same will always form a rectangle. But with parallelograms, there's more than one way to chop it and rearrange it and get the same answer. Okay, so I want you guys to take a second and try and do the second one next to it while I try and make mine look like yours. Girls, get it together. Okay, Ella, where'd you cut yours? Straight down the middle or where? Like, I'll just put my pencil up here. Did you cut it here?
No.
Right here?
Yeah.
Okay, so she cut it right there. And then what did you do?
I took that side of the triangle and put it on
So you took this side and moved it over here?
Mm-hmm.
Okay, and I'm just going to count 1, 2, 3, 4, 5. So I need 5 across the top. 1, 2, 3, 4, 5, and then I go down. So she has this rectangle right here. That's gone. What is the length and the width of your rectangle, Ella? 3 by 6. So what was your area? 18 square units. Raise your hand if you got 18 square units, but you cut it different. Okay, Cooper, where did you cut yours? I'm going to clear this. Where did you cut yours, Cooper? I'm going to just draw her line in. So she cut it here. Where did you cut it?
On the other green circle.
So up here? Yeah. Okay, so you cut it there, and then what did you do? What did you move? So you took this and moved it over here? Yeah. Okay, so 1, 2, 3, 4, 5 straight lines. 1, 2, 3, 4, 5, and up. Does he still have a 6 by 3? Yes. Yes. Livy, did you do it different? Okay, where did you cut it?
I cut it right in the middle on both the green dots, like the one that's right under it.
So you cut it where the red line is?
No, like the top, like the green part. I did it a hard way. Like the green part in the corner on the top.
Okay.
And then I cut it down like right below there, like right in the middle. No, like it went diagonal.
So you cut diagonal.
Yeah.
Okay. So yes, you made it a little bit harder, but that's okay.
And then I moved the triangle to the other side and realized that was bigger, but then it fit but then the extra part that was left, I realized that fit in the one part, so then I resliced it right.
So was there an easier way?
Yes.
Okay, so Livy got there. She just went the long way around the block instead of in a direct line to it, but she got there. Do I care how you get there? No, as long as you get there and can explain to me or your work shows me your thought process. Are there wrong ways to do this? Yes. I couldn't have cut it like here and moved that to the top because then it would have just been,
Same thing.
yeah. And actually it would have been like this. Well, I guess I could have shifted it, yes, and it still would have been like that. Okay? Look down at the next example at the bottom. And this is where I think mine is different than yours. Let me,
You just have this same that's on the next page.
Yeah.
no, but I think, let me count yours. 1, 2, 3, 4, 5, 6. Maybe it's B. A or B is different on mine than it is yours. So somebody count real quick from here to here.
6.
So 1, 2, 3, 4, 5. Okay, it's 5.
Wait, including the half one too?
You're just counting a distance. So remember, when we're counting a distance, we don't count till we move. So we count 1, 2, 3, 4, 5. Is your guys' 5?
Yeah.
Okay. What is different about this parallelogram and the two that we just did? Sophia, what's the difference between A here and the two that we just did above it? Do you see anything different? You don't see anything? They're very, very similar. Ethan?
It's just angled weird.
For A? Yeah, it's just rotated, okay? The ones up top, the flat sides is what you guys would probably call them, are on the top and bottom. This one's just rotated 90 degrees. It's just turned. Can I still decompose it and rearrange it into a rectangle?
Yeah.
Stella, where do you think I can cut this one?
Right. 2 down.
Okay, so cut it horizontally. Yeah, if I cut it right here, she said 2 down from the top. She's chopping off that right triangle. Where's she going to have to move it, Reese, to make a rectangle?
To the bottom.
Yeah, to the bottom. Have to move it right down here. Let's draw it in. Now we have a new rectangle. Ethan, how do I find the area of a rectangle?
A equals length times width.
A equals length times width. What are my dimensions?
3 and 5.
3 and 5. What's 3 times 5?
15.
15. What's my label?
Units squared.
Units squared. Okay, so just a second ago I told you probably 95% of the time, a good percentage of the time, you will be able to chop it, make it into a rectangle. And then we get to long, skinny, spread out ones like B. There are lots of ways to find the area of B. We can turn it into lots of little tiny rectangles, or we can box it into one big rectangle. Okay, we're going to go with that method. This is one where if you chop it and rearrange it, no matter where you chop it, no matter where you rearrange it, you'd have to chop it and rearrange it a couple times to get it into a shape of a rectangle or a square, okay? So on these weird ones, and you'll notice they're weird because they're always long and skinny. Long and skinny. Create a box, a rectangle around the whole shape. So I'm going to go up from this tip at the bottom just like that. Okay, so I just created a rectangle around the outside. But I'm looking for the area of just the blue piece. So who thinks they have an idea on why I would possibly do that? Sophie?
So you can count the squares instead of having to do 1/2 since the squares on.
Okay, well, we're not counting squares because they won't always be on squares.
Oh, count the area.
Okay, so she's saying to count this distance over here. Can we count that distance?
Yes.
Okay, you guys go ahead and count it because I think this is the one where mine's different than yours. I have 6. What's your height? 6. Okay. What's your? I don't think it's 10. You don't count till you move. So put your pencil on the first corner. You don't start counting till you move. So count 1, 2, 3, 4, 5, 6, 7. Mine's 8, but I think yours is 9. Is that correct? So I'm going to label mine 9, even though mine shows 8. This is where my book is different than yours. If I take 9 times 6, what am I finding the area of, Nolan? If I take 9 times 6. Yeah. So let's start with that. Let's start with A equals L times W. 9 times 6, frequently missed problem. 54 is correct. Okay, but like Nolan said, if I do 9 times 6, that is, let me make this bigger. That is all of this. The area of all of this is 54. Do I want all of it?
No.
No. I have all of the yellow. What do I want to get rid of? Livy?
The 2 side parts. But
The 2 side parts, which are which shape?
triangles.
More specific.
Right triangle.
Right triangles that are the same. We have to get rid of the 2 identical right triangles. Why do you think I made her word it like that? That they are 2 identical right triangles? Because if you have 2 identical right triangles, you can make it into a rectangle. So in our notes, we're going to draw an arrow out here. Oops, that's a really big arrow. And write white triangles. If you take those 2 white triangles, we're going to draw them, and we smash them together without the blue part in the middle. So I'm going to, if I could, I'd pull this blue part out, push those 2 white triangles together. What would the dimensions of that rectangle be? What would the dimensions of that rectangle be if I slide that blue piece out and I push those 2 right triangles together to make this rectangle? What would the length and the width be? Max, what do you think? What would the length be? So this distance down here. Okay, look right here. If I took this blue part out, so let's just pretend we're sliding it out, and I push those yellow pieces together. What would that do to this distance down here at the bottom? It will change it, but what will it change it to?
5?
Not 5. Why 7, Ethan?
Because from like the bottom blue one
Yeah, I'm getting rid of those two bottom pieces. Okay, when I pull out that blue section, I'm getting rid of those two blue pieces. So the bottom of my white triangle, or my white rectangle made up of my two triangles, would be 7. Would this number change?
Yes. Yes.
So Ethan, if I pull out that blue piece and push these together, would my triangle get shorter? No. So you guys are correct. That would stay the same. Now we have a rectangle that we can find the area of. 7 times 6 is 42. Now I have two numbers. I have to decide what to do with them. Chase? Why?
Because you took the blue part out and now you have to get it back in.
Yeah. So the 54 is everything. Now I know the area of this piece and this piece is 42. So yeah, if I subtract those, I would have my remaining piece that I need. So 54 minus 42 is 12 square units. Those ones are tricky. And like I said, there's other ways to do it. After you guys get that copy down, I'll start to show you, but and only if they're like perfectly cut in half, like this one is. Everybody have that? So the other thing we could have done, and again, even though that way was long, it typically makes sense. I could get rid of that piece and add it on there. I could get rid of this piece and add it on there. So now I have 4 by 4. I could get rid of that piece and add it on there. I could get rid of that piece and add it on here. So now I have another 4 by 4. I need that one to go there, so that one's gone. That one can come here. That one's gone. 4, 8, 12. Same answer. Okay, but you have to decompose and rearrange a whole lot of little pieces. Again, if that makes sense to you and you feel like you could do that, does that way work? Yes. Chase.
Couldn't you just slide the triangle the other way with the patty paper?
Slide what?
The triangle upwards?
No, because they're diagonal.
So, and if you guys notice, this is one where it is cut like on the diagonal. See how it's perfectly on the corners? Like it goes from corner to corner. Those ones are the ones we like because they make our life easier. I think this is what Chase meant. We could cut it. Chase is saying I could cut off that right triangle and put it here. If I cut off this right triangle, I could put it there. If I take these two right triangles, could I rearrange them right there and have that rectangle? Does that work? Yeah. Okay, those ones are just tricky because you can't just make one chop and rearrange. There's lots of chops, lots of rearranging, or enclose it, take out what you need. Look at the top of page 33. Top of page 33. We took it off the grid, but it is a parallelogram. So what do we know about parallelograms? You can chop and rearrange. Let's chop it where they already drew us a line. Could you use your patty paper to make sure this fits? Where should it fit? Perfectly on the other side. So we're going to chop it. We're going to move it over here. And again, you could use your patty paper. Why would most people not like that for the way this one's set up? Because when you're trying to find the length and the width, Ethan? So yeah, this is 6, and we need this. So we kind of chop that 6 in half. What should it be? It should be 6. If I show it this way, it's the same thing. If I chop it here and move this over here, Now I can see that it's 6, but I need this distance or this distance. What are those distances? 4. What is 4.5?
That's the diagonal.
Diagonal. Can you ever give a height as a diagonal?
No.
Why not?
Then it won't get tall.
Your doctor tells you to
Stand straight.
stand up straight when he's measuring your height. So this one would just be A equals length times width. 4 times 6. 24 units squared. So is this really any different than what we've been doing? No, it's not. Not even a little bit. Turn the page over to the practice problems. Circle number 2. Then turn the page to the problem 6. Circle problem 6. Now you guys have a whole bunch of white space at the bottom. Shh. Draw a line down the center. Draw a line across to create 4 boxes. They don't have to be huge. You can use the whole bottom. You don't have it or have to. Label them A, B, C, and D. Number 6 says find the areas of the rectangles with the following side lengths. How do you find the area of a rectangle? Length times width. Do we know how to multiply fractions? Yes. Okay. So your homework is just those 2 problems. Unit 1, lesson 4 practice problems. Number 2 and number 6. And then your IXL skill G1 is due
2 days.
Friday. Okay, if you have it done, you can go ahead and turn in your sheet with your work page. But again, you have until Friday. I will not see you in class on Friday, but I will have Miss Dillon and Miss Locke collect those. Okay.